Hi guys, today I want to cover displacement, the vertical displacement for this bar or for this system, and to explain you again how to use method of joints in order to determine the unknowns in this system. So this is something which you have in thread of materials. I think it is chapter number 4, the chapter which covered the displacement, and you probably know that you have your equation which will be delta is equal n times L over modulus of elasticity times area. So here we have a rigid bar which is supported by the pin connected rod CB that has a cross-sectional area of 500 millimeters square. So your A is 500 millimeters square, which is, in order to obtain meter square, we need to multiply with 10 on minus 6. So that is for the meter square. And we have 836 still, which means your modulus of elasticity will be 200 gigapascal. So this is known values. We need to determine the vertical displacement of the bar at B when the load is applied. So you have a distributed load of 45 kilonewton per meter. And we have a length of the bar BC. Since that we have triangle 3, 4, our diagonal has to be 5 meters. So we have length, we have modulus of elasticity, and we have area. What we don't have is the force from B to C or C to B. So firstly, what I usually say to my students, that they have to draw free body diagram. According to this system, you will have a vertical force AY, then you have a horizontal force HI, and you have a force from B to C, and we have a distributed load, which is given here as 45 kilonewton per meter, and we have a length of 4, so that means our Q force is 45 times 4 over 2, which means Q is 90 kilonewton. So this is our Q, and we have that force on 1/3 from the right angle. So that means we have 90, and we have this distance to be 4/3. So here is 4/3. We have force from B to C, and we can say that this is equal force at the end from C to B. Why? Because we have a bar which doesn't have any load, and using the method of joints, we know that this type of bars can be subjected only to compression or only to tension, and both forces need to be equal. So force from B to C is equal to force from C to B, and we are assuming that we have a tension force, so that FBC is in tension direction. So according to this is our free body diagram. So that is what I recommend usually to do firstly when you have a problem like this. The next step will be to write equations of equilibrium. So we have 3 unknowns, and we have 3 equations of equilibrium, so we can determine all unknowns using these 3 equations. So sum of forces in x direction is equal to 0. What we have is force HA, and we have FBC times cosine of the angle alpha. So since that we have the total length here 4, and we have a height of 3, we have this triangle, so 4, 3, 5, and your alpha, cosine of alpha, will be 0.8 or 4/5, and sine of angle will be 0.6. So this is the only two horizontal forces. We have these two to be equal to 0. The second equation will be sum of forces in y direction is equal to 0. So we have AY, we have plus FBC times sine of angle, which is 0.6, to be equal 90 kilonewton, which is our distributed force or our external load, and we are done here. The third equation will be sum of moment at point A is equal to 0. So which forces will make the moment at point A? So that is our force of 90. It is clockwise. We can say 90 times 4/3. That is the distance, and that will be the first moment. The second moment, since that we have force FCB, so this force FCB is FCBY, or it can be split into FCBY and FCBX. So FCBY will have the moment, and it is opposite than our force of 90, so it will be minus FBC times sine of angle, which is 0.6, and times 4 is equal to 0. So now we have three equations and three unknowns, and what we have to solve is FBC. So using the third equation, we can determine easily how much is our force FBC, and that is the force which you will need to use in order to find the displacement. So the third equation, FBC times 2.4. So we have FBC times 2.4 to be equal 120. 120. So our force FBC is 50 kilonewton. If you want to find the other unknowns, AJ and AY, you just need to plug 50 instead of FBC, and you can easily determine the other unknowns. But since that we don't need for this problem, we can say that our delta is 50 kilonewton, which is 50 times 1000 Newton. Then we have length, which is 5 meters. So 5 meters. Then we have 200 gigapascal, which is 200 times 10 to 9 Pascal. And times area, which is 500 millimeters square. In order to get meters, we are multiplying with 10 on minus 6. So this will be all knowns now. What we need to find is only to calculate the value. And I think that it is 2.54 times 10 to minus 3 meter. So this will be the value of the displacement at point B. Displacement at point B will be something like this. We will have delta X and delta Y, and we found this displacement of 2.54 times 10 to minus 3. So in order to obtain delta Y, we need to find vertical displacement. We need to divide this 2.54 over sine of angle alpha. So that will be the value for your displacement delta Y. If you need to find the horizontal displacement, then you will divide this value with the cosine alpha. So I'm not sure if we got the right answer at the end because I didn't calculate, but what I recall, since that we had this problem on the exam, I think that it was around 2.54. So this is one way how to solve the displacement. Again, the part which belongs to strength of material is only equation n times L over E times A, but everything else was statics. So how to determine the forces when we have a system like this? And if you have a bar like this, you need to know that this force from B to C is equal this force from C to B when we have no load on the bar. If we have some moment, force, or anything else, distributed load, these two values of the forces will not be equal, and we will have then four unknowns on the system and three equations of equilibrium, which will be indeterminate system. So this, I wanted to do this video. I gave this to my students on the first exam on strength of materials. And what I could notice that all of them struggle how to find the internal forces. So that's why I prepared this video. If you like the stuff, subscribe, or you can even put a comment and I will reply if you don't understand any part of this video. So thank you for watching and have a great one.